I'll give a quick intro about myself, and then we'll go ahead and let everyone else introduce themselves and jump right in. My name is Cami. I'm the head of developer relations at Fuel Labs, where we're building Fuel, the fastest modular execution layer. And you can think of it as basically an engine for execution that can plug into any chain, and all it does is handles execution. We'll get into more maybe about Fuel in this conversation, but I want to turn it over to Nick so he can give an intro and about himself and Celestia.
Hey everybody, this is Nick. I'm COO of Celestia Labs. We're building Celestia, which is the first modular blockchain network, and it's a universal consensus and data availability layer, which is intended to make it really, really easy for people to build their own blockchains. So execution layers like Fuel can simply deploy a chain and plug it into Celestia rather than bootstrapping their own consensus network from scratch. So our vision is to really unlock tons of innovation and new chains and sovereign communities, which I'm sure we'll all get into.
Amazing, thank you. Neil, could you give us a brief intro on yourself and into Eclipse?
Yeah, so I'm Neil, CEO of Eclipse. I used to work in traditional finance, was doing commodities research over at Citadel, left in March, was briefly building in the Terra ecosystem, was building an EVM in Terra. When Terra depegged, scrapped that project. Nick actually reached out, got familiar with the Celestia project, and basically saw the light that rollups were the only viable path to scalability for crypto. So I was in Chicago at the time. I was chatting with some Solana core folks, a bunch of Solana protocols, and they were expressing the desire to have their own version of Solana. As we saw, like Pyth do. Pyth was using 10% of the Solana network. They're an oracle on Solana, and they announced they're going to move off and make their own thing called PythNet. Now they have to manage all this infrastructure. So that's basically what Eclipse is providing. It's like your own version of the Solana execution layer, but you can use any base layer such as Celestia or Polygon Avail or something else.
Awesome, thank you for that. And finally, Arjun, could you give us an intro on yourself and Connext?
Absolutely. I'm Arjun. I'm one of the founders of Connext. Connext is a modular protocol for cross-chain communication. Connext basically is a system that plugs into the best underlying mechanism for like verifying messages that go across chains. So like rollups in the Ethereum ecosystem, rollup bridges in the Ethereum ecosystem, IBC in Cosmos, I guess IBC in Celestia as well. And then builds an execution layer on top of that for developers to build cross-chain applications. So our vision is that the future is going to be made up of applications that will live on multiple chains simultaneously, and that will like communicate asynchronously with resources that exist in multiple different ecosystems, because that's just really how the internet is built today. And Connext is the best platform to do that with.
Amazing. Okay, love Connext, love Arjun. Okay, let's go ahead and just jump in. Modular Blockchain 101. If you're here, you probably have heard the term before. You probably have seen it on Twitter, but just maybe so we all start at the same base level and we can make sure that everyone has an equal understanding. Maybe Nick, could you intro and just talk at a 101 level? What is a modular blockchain first? And then two, why do they matter? Why are they kind of taking Twitter by storm? Why is it kind of like the next topic that's heating up?
Sure. So to start, to understand what a modular blockchain is, we kind of have to understand where we came from, which is monolithic blockchains. So every blockchain that's been built so far, Bitcoin, Ethereum, Solana, et cetera, most of the ones that you're familiar with, are built in this paradigm where the network and the nodes in the network do all the responsibilities at the same time. So they come to consensus on blocks, they ensure that the data behind those blocks is available, and they also execute all the transactions, like they run the applications and the state transition function. So what the inside of modular blockchains is that actually you can break those functions into separate protocols and separate layers. And by doing so, you kind of get a ton of benefits that monolithic blockchains basically struggle with. So the problems that monolithic blockchains have are, first of all, scalability. So they kind of, in order to increase the throughput of a monolithic blockchain, it inherently causes centralization. And modular blockchains, for the first time, can actually increase throughput without causing centralization. The other thing that modular blockchains have that monolithic blockchains don't is this customizability and sovereignty. So when I'm building on a monolithic blockchain, I'm locked into a specific execution environment. So that would be either EVM or the Solana virtual machine. And I cannot actually, as a developer, build something on a different execution environment. I'm locked into that ecosystem. And in a modular blockchain, the developers can actually choose to build in whatever execution environment that best suits them. And then the last thing that modular blockchains have is this notion of shared security. So you can deploy a bunch of separate blockchains, a bunch of separate execution layers, but they all plug into the same consensus network at the end of the day, the same data availability layer. And that gives them this ability to bridge in a trust minimized way, and also reduces the overhead for them to deploy a new blockchain, because you don't have to build up that whole security layer from scratch. You just plug into an existing one.
Perfect. Thank you for that. And then maybe Neil, could you introduce the concept of a customizable modular rollup?
Yeah, so like Nick was saying, Eclipse is building modular rollups where we split up execution of programs, settlement, which only applies to rollups, and consensus and data availability, which is basically storing blocks and then also providing data availability proofs. So basically we make it so that because we factor out settlement, we don't do settlement on the L1. So if we built this as like an Ethereum rollup, we'd have to actually implement a smart contract on the Ethereum L1 that's able to execute Solana bytecode. And like the process of settlement is basically saying if let's say an executor lies, then the settlement layer can determine whether like what the truth is and what the correct state transition function should have produced. So if we don't, because we don't do that on the actual L1, we're able to factor that out and just use the L1 for data availability. And there are a few chains that are going to be providing data availability. Celestia, of course, is like our favorite. But you could give like an optimistic data availability proof. You could give a zero knowledge proof, like some kind of KZG commitment. And there's like different L1s that provide different types of DA.
Thank you for that. And then maybe Arjun. So Nick mentioned just now earlier, he talked about when you have these different blockchains and they have a shared DA layer, you can do trust minimized bridging. For you and the cross-chain world, what do you expect cross-chain communication to look like and feel like within this new modular paradigm? What will be different? What will be
Yeah, that's a really good question. So I think to answer that, first we need to look at like the way that bridges are built today, and then also like what like people actually need, like what users actually desire, and like how we can kind of bridge the gap to getting there. No pun intended. I think what exists today is like, similar to monolithic blockchains, monolithic bridges. People have like full stack systems that do everything associated with taking data across chains. And that includes like taking data, like just posting data from one place to another, which we call transport, ensuring the correctness of that data, which we call verification. And we've talked about verification in like this post that we put out last year called the interoperability trilemma, which just like outlines a bunch of different verification methods. But then beyond that, there's also like other pieces associated with bridging. So one of the things that a lot of people don't think about is execution. So how do you actually take this like small piece of data that was posted and verified across chains and then do something with it, call a contract function on the destination chain, and pay the associated fees with that in a way that gives like a good user experience. So in other words, in a way where you're able to pay those fees from the chain at which the call originated. And then separately from that, how do you ensure that you actually have like other pieces like liquidity? How do you make sure that you get the right asset across chains so that you're not dealing with like a fragmented ecosystem of multiple different kinds of assets? Because bridges today try to like do all of these things, they're able to provide like a good solution for every chain, but not the best solution for any chain. And specifically, I think this comes down to the verification property. And this is what ties into what Nick was talking about around trustless bridging. There's a lot of different ways to verify messages that go across chains. But ultimately, the most secure mechanism to do that is always going to be rollups. And that's because, and this is even more secure than light clients, even more secure than IBC as it's constructed today. Because under that model, even if the rollup sequencer, I guess whoever is responsible for the message from an origin chain, even if that entire ecosystem decides to go rogue and produce a false update, that gets relayed across chains, and they all come to consensus on that update, a rollup specifically penalizes that outcome because there is no consensus. There is only an update that is coming from a single party. And I think that that's a really important point. And what that kind of leads us to is this idea that there is a best verification mechanism for each ecosystem, and that each ecosystem will have its own kind of like underlying slightly heterogeneous mechanisms for how to do that. But broadly speaking, because there is a best solution for each ecosystem, what we need is a system that can plug into that verification mechanism to be able to provide the most secure option available for every ecosystem. So how does bridging look in this kind of a world? Well, we think that like communication that goes between chains should be separated. This is an idea that Celestia introduced last year. But we think that communication that goes across chains and across domains more generally should be separated into like intercluster and intercluster communication. We think that the verification of messages that go within a cluster and then also outside of a cluster need to be treated differently. But we think that from a developer's perspective and from a user's perspective, that should all look exactly the same. And it should feel exactly the same. So you should, as a dev and as a user, you should be able to like benefit from having the security that each ecosystem like Ethereum or Celestia or Cosmos provides without having to be tied to the security of the underlying bridge.
Perfect. So yeah, can you maybe talk about, it's just interesting because, you know, Celestia is in the modular, Fuel's in the modular, Eclipse is in the modular, and then Connext also interestingly uses the term modular a lot to describe the architecture. I know you briefly touched on it, but can you just like maybe give us 1-2 sentences on what exactly that means for a bridge and how you can plug and play?
Yeah, absolutely. So like, for instance, right, Connext today, basically, as I mentioned earlier, plugs into like the best system for an underlying chain, for an underlying ecosystem. So for example, when going between Ethereum and Optimism, we plug into the Optimism bridge. So the Optimism bridge is basically how a message gets from Ethereum to Optimism. Connext provides the interface that developers call into, and they provide like the execution layer, which basically unpacks that message on Optimism and does something with it, right? Now, of course, that message going to Optimism doesn't actually get posted immediately. That takes a certain amount of time, and then depending on the rollup and depending on the like the type of system that you're using. So, for example, like zk Sync exiting from zk Sync to Ethereum will likely take like 15 to 20 minutes because zk Sync will have to post batches of updates to Ethereum. So in that kind of case, like you're now saying there is a 15-minute latency for a user to be able to like send a message. What Connext does is that our execution layer basically just abstracts all of that. As a developer, you just send a message from one domain to another. We find the fastest and most secure mechanism to get there. And in addition to that, in specific cases where we are able to do so, we'll shortcut that mechanism altogether and have like our own network of routers, which are our nodes, basically front the transaction and then be repaid through the bridge. This is sort of similar to like how Hop works, where Hop provides like fast liquidity for an exit from a rollup. Except in our case, we also do something a little bit more interesting than that, which is like some types of fast execution. So the kind of like TLDR of that is for Connext, modularity means being able to utilize the underlying rails of things like rollups or like client bridges where they're available for message verification and security, where Connext focus specifically on execution and liquidity.
Thank you for that. Okay, maybe open question to anyone here. What are the most promising use cases for modular blockchains? What will modular blockchains unlock that potentially at this point hasn't even been, talked about, or at this point just can't be done with that level of efficiency or security?
I think gaming is really interesting. Gaming is interesting because for like a fully on-chain game, the throughput requirements are super high. So you might want to have your own like custom rollup for that reason. And they often don't have that many composability needs. And if they do, it's like different dApps or different contracts that the game developer themselves is deploying. So it's like maybe some in-game assets, so NFTs. Maybe they have like some sort of like, I don't know, some sort of onboarding, like on-ramp, off-ramp that they use. But you can deploy that all to their chain. Maybe at the most they require some kind of club or some sort of infrastructure like that. So that's interesting. I also think that there's some like areas in DeFi. Maybe if you want to do like frequent batch auctions within the sequencer, that's really well suited to a rollup, because you don't really want to spin up an entire L1 if that's the only feature that you're providing. So those are two areas that I think we're going to see more innovation in.
Yeah, I can't share too much, but I'll just kind of expand on those 2 points. One is there is a team building a execution layer that is focused on gaming, and essentially they're customizing their execution model to basically be more fit for like gaming itself. So like essentially, yeah, I think it's like too much alpha. It's kind of private, but like these kind of things where developers need to kind of go down into the inner workings of the execution environment and modify it so that like it's more suitable for a specific use case, or where that's or some of the use cases are really going to be enabled by modular. I mean, another example is I was also speaking to a DeFi founder the other day, and there were certain things that he was trying to do in the EVM for the longest time, and essentially it's just like it's possible. It is very painful and just not like ill suited. But if he was able to take the EVM and then make some modifications, then all of a sudden his use case becomes like very, very possible and very efficient. So it's things like that that I think are going to be uniquely modular. But beyond that, I think the thing about modular too is that it's just going to make every use case cheaper. So it's going to make using blockchains so much lower cost that certain use cases that previously were just either prohibitively expensive or just not really feasible given the current costs, all of a sudden they become feasible again. So those are kind of the two different directions I see modular blockchains enabling new applications.
Yeah, that's actually what I was going to echo. Like the whole idea behind modular blockchains is like it is the theoretically optimal solution to trust minimized scaling of blockchains, right? Like this is basically the thing that we have all of us really have kind of been like researching and thinking about over the course of the last, I don't know, 6-7 years now. I mean, longer if you include a lot of the Bitcoin stuff, but I think like we've come to this conclusion that that like modularity and that moving towards this like hierarchical superstructure of like many like composable rollups that are like many rollups that are that sort of live on top of this like shared DA layer that itself lives on top of like a shared settlement layer is like is the best kind of superstructure for scalability. And so really what this is it's a solution for this like pain point that we've all been experiencing around not like our blockchain not being scalable enough to do all of the things that we wanted it to do in the past. And I think like when you start thinking about, okay, what are the things that we wanted blockchains to do in the past that we were just sort of like priced out of doing? There's of course all of the things that we use today, and many of which like during bull markets were priced out of using. But even beyond that, there's also like so many of the more kind of like fantastical applications of blockchains that have been talked about for a very long time, but have just not really been like valuable to do because the cost of them, the base cost of them is just too high. And that includes a lot of really interesting things like I'm very interested in like persistent APIs to like persistent data on chain. Like historically, it's very, very difficult to have like shared data sets on chain because of the overhead of having to store that data, the overhead of having to like interact with that data, and to like be able to manipulate that data in a way that like makes sense and isn't like going to cost like tens of dollars to do. So that's I think something that's super interesting to me. Like a good example of this is like what's like a decentralized Wikipedia alternative is a really, really interesting use case that I think like could become popular in possible in a modular environment. Another one that I'm interested in is legitimately public goods artificial general intelligence. So like have a neural net whose weights are recorded on a rollup. Feed it data sets from off chain. You can provide proofs that those data sets are processed correctly. And then, these neural nets, like the neural net weights are kind of like publicly available. Anybody can come and like train this data set. And over time, it can become basically like a more unstoppable version or a completely unstoppable version of something like OpenAI. I think there's a lot of work to get there. I think that would require a very custom rollup, but those kind of like world computer use cases are the ones that I'm personally most excited by.
Every time we do a space, I'm like, I swear, the feature I would pay for is the custom little reaction emojis, because I would literally die for a purr, because y'all are just, there's just some pieces that you really want to purr to, where it's like, damn, this, they're really spitting. Like, anyways. Okay, another question, everyone. What are the biggest challenges and obstacles that we have in building modular? Like, for example, Fuel's on testnet. I think Celestia is also on testnet, if I'm not mistaken. So we're still very much so in the early days. And as we're thinking about building modular, what are the challenges that we're seeing or that we predict that we're going to need to overcome to actually build modular?
I think one of the biggest challenges out of the gate is that it just takes a long time to get to this point, right? Like you don't, for anybody, I mean, like modular is sort of like a word that we are using to describe this idea, but like the core principle is basically like an engineering concept, right? Which is you go and you build a system, and over time, as you develop that system and you understand the design space better, and as you understand like the right way to build the system in the first place, the system that you're building becomes more and more efficiently organized internally so that it becomes more modular, right? And so you can like update it and replace it and improve on it in a more kind of like efficient way. And like that is a process. Like you can't, unfortunately, there isn't any way to like from like a blank canvas build a modular blockchain if you don't know anything about how to build blockchains. So I think it's like kind of similar for both blockchains and bridges, that like one of the challenges is you have to go through the pain of building it the wrong way first, and seeing what's wrong with that and experimenting with it to get to the point where you're like, okay, this is the right way to build a more modular, more efficient system.
Yeah, agreed that like the tech's just about to get there. Like settlement layers like Eclipse is doing for the Solana VM or Astria for the EVM are like still not done yet. So that's one thing. And then the other thing that's like often a barrier for people to move to a modular rollup is just the composition. I think once we have better composition, like atomic composition between like rollups and monolithic chains or something like that, then the barrier is much lower. But I don't think that exists yet.
Yeah, my perspective on this is that the modular vision is so grand, and when we get there, it's going to be, I mean, it is the end game for blockchain infrastructure. However, there's a lot of like deep technology and engineering yet to be done. I would say a lot of the research is there, but then taking research and implementing it and putting it into production is no small feat. And so there's a lot of work to be done on just the implementation piece. And that's why, but the cool thing is that like literally every month there are more and more teams working on all the different problems, from data availability stuff to execution layers to bridges and all that, and settlement layers. And so it's really exciting to see the amount of work that's being done. Aside from that, there's also one thing, which is that modular blockchains just blow the door open in terms of different designs. Like there's so many, I guess, different approaches to building these things and so many different sets of trade-offs, and that it can almost be, it's almost overwhelming. It's like the paradox of choice. It's like there's almost, I think one of the problems we're going to have is that builders are going to come to the modular ecosystem and be like, whoa, like there's just so many options to choose from, like what do I do? And so I think that's something that we need to kind of align on, is like a set of standard interfaces, a set of standard perhaps like products that make it a little bit more legible and digestible for developers who come into the ecosystem wanting to use these tools.
Yeah, that's actually a really important point, because like you have so like a good like example of this phenomenon is like how the DEX market has evolved. So like in the earliest days of DEXs, people were basically trying to build like order book exchanges on chain, and of course those were horribly inefficient. And because like it was just really, and like because it was extremely expensive to do that, people moved to like moving order books off chain, but then you can't decentralize that order book, so there's a lot of complexity. And like while that was all actually the right like solution, it was sort of like, okay, let's give the idea was like, let's find a way to give the most efficient pricing. But that's not really what users needed in, 2017, 2018, 2019. What users needed was just some way to transfer asset A to asset B. And so the systems that won were things like Uniswap, which were, let's not focus on optimal pricing. Let's not focus on optionality. Let's not focus on like institutional clients. Let's just focus on doing this like the dumbest, simplest way possible at first. Basically like restricting user choice as much as possible until the market evolves. And it's kind of interesting because it's like, if you fast forward a couple of years later, this market has now moved to the point, it's kind of matured to the point where now people care about optionality. Now we have a market of like institutional investors that wants most efficient pricing possible. And so now it makes sense for things like UniV3 and other kind of like concentrated liquidity dexes, and eventually even like more on-chain decentralized order book dexes to exist. Because now people want the like privilege of choice. There's enough of a market that they want, that they care about this. So I suspect it's probably going to be the same kind of with like modularity in general. Is we're probably going to have like a defined user pathway initially, and over time work to add that optionality as the market evolves and as like people's understanding of the infrastructure matures.
Purrs, Nick, love to hear it. Literally love it. This is why you guys need the custom purr emoji in your Slack so you can have it. I know Fuel already does. Okay, speaking of challenges, so we talked about challenges. Now, ecosystem-wise, when we think about ecosystem, what tooling or other protocols need to be built to kind of get this modular vision up to par? And like, how do we accelerate this? What tools are missing? What protocols do you want to see built in the space?
I think one simple one is just sequencers as a service. So some sort of container orchestration to easily spin up a modular rollup. I think Nick has tweeted about it a bit. We did a like a Twitter space with Saga a couple of days ago. So that's one. Another is just basic infrastructure like block explorers, like what Celestia Scan / Modular Cloud is working on, and we're working with them pretty closely. And then I think if there's just some tech missing to enable some of the cool use cases for modular rollups, like some sort of KYC for rollups to enable permission blockchains. Like for, I don't know, for commodities trading, for example, hedge funds aren't allowed to just like trade against retail. So having some sort of KYC and a permission chain so that they're only trading against each other, I think would be really useful. And just like more data availability layers, like more options for that to enable like extremely high reliability, so that if like an L1 goes down or something, then you have that optionality to switch over.
I'll echo Neil's point about the sequencing as a service, because our grand vision, right, and one of the promises of modular blockchains is that it's going to make it possible for anyone to build their own blockchain with basically no overhead. Like we want to make it as easy as it is right now to deploy a smart contract. So like, on Ethereum, you just go there and you just like write your code and you click deploy and you're done. And the modular blockchain, hopefully we can get to that level. The thing that's still kind of holding us back is that there is some minimal infrastructure required to like launch a rollup, and that is that you need sequencers. And so hopefully what we can have is some kind of like sequencing as a service platform, or actually many of them, that make it so that I come as a developer with the sort of like code for my chain, and I just click go and someone spins up the network for me, and it plugs into the I configure it to plug into a specific data availability layer and everything else. But I think that's still kind of like the last link to make deploying a blockchain as easy as it is to deploy a smart contract.
It's so interesting that you guys mentioned sequencing as a service, because that's something that I've been like really, really keenly interested in for quite a while now. I talked about it at a couple of panels like almost a year ago, and I think like people laughed at me because they were like, "Why would anybody do that?" And I was like, "It's an extremely lucrative business. It is like it's like sequencing is going to become like it's obviously the future of like node operation, right? Just you'll have node specialization, and then like having nodes specialize into sequencers makes a lot of sense. And like if you're a sequencer, if you're sequencing like one of these large networks, you would be making a ton of money on doing that. So it's an extremely lucrative business with like relatively low overhead compared to, I mean, it's just like proof generation, right? So it's like relatively low overhead compared to actually like running a chain. So you can basically just take you can build a network for sequencing as a service, take the model, give it to everybody that is already running on like node infrastructure, right? Go to Dokia, go to P2P, go to Stakefish, et cetera, and just be like, hey, run this as well. And they would be making like you're completely cutting like 80% of their cost basis out of the equation. It's pretty amazing. By the way, if anybody is interested in building that, please reach out to me because I'm really would love to just like talk about it. I think it's quite an interesting idea. Yeah, separately from that, let's see, on the chain side, I think one of the things that's really missing right now is like good discussions and standardizations around how like roll-up to roll-up communication should happen. We've been trying to work on that a little bit ourselves, and I think every ecosystem has been trying to basically work on their own system for that. And what we found is like pretty much everybody is like has the same ideas and the same solutions, but I think like standardizing there would help a ton because it would just like cut a lot of overhead out of building modular bridges like Connext, and it would also cut a lot of overhead out of security. So like the more kind of fragmented like more kind of fragmented experience you have around roll-up to roll-up communication, even if it's like kind of like slow passing message routes between rollups, the more kind of like non-standardized that is, the more likely it is that you are going to like create some sort of security vulnerability when you're implementing it.
Yeah, so the way that we're doing that with Eclipse is we implement IBC, and we got like a Solana Foundation grant in order to do that. And like you were mentioning before about like intra-cluster versus inter-cluster communication, for like intra-cluster within the cluster, we like allow like fast finality of the message, or I guess not fast, but you can basically pass a message to another Eclipse chain immediately. Whereas if you're going outside of the Eclipse cluster, then there's like this challenge period, which is the same as the like regular optimistic rollup. And then sorry to go back a bit on the sequencer as a service thing, but I think the way it should look is some kind of interchain security fee market where there's actually the efficient market price for sequencers is calculated whenever you want to deploy a rollup, and maybe it's continuously updated, something like that.
How would you create that kind of a market? Its own rollup?
Yeah, I guess. Yeah, you'd need to have some place where a club lives, some sort of like order book to facilitate the market. And then I think it should be something like you demand K quantity of sequencers, and then there's like however many sequencers in the market they have like their own marginal costs, and then you apply some kind of uniform clearing price to all the sequencers.
Yeah, that's true. At the risk of oversimplifying, though, you could honestly just start with like round robining. I mean, of course, like there is a risk that as a sequencer, or just maybe even just stake weighted selection, but there is a risk as a sequencer that you end up like missing out on a set of updates or like a batch that is highly valuable compared to like others, but it's probably like an optimization that you can improve on in the future.
Yeah, I agree. And you'd also want to get the incentive right. Like you don't want to be paid in like whatever, I don't want to call it like a shit coin, but whatever the roll up initial like form of sequencer fees is probably not the most valuable thing. So you want to somehow compensate the sequencer in some additional way too.
Yeah. Okay,
I hope someone's writing this down because there's a white paper in here somewhere.
Okay, yeah, I was gonna say I feel like in that discussion we kind of only got to one answer in the question of like what tools or protocols need to be built. We talked about sequencer as a service, but what else? Anything that's like, yes, this tooling is desperately needed, and when someone figures this out, it'll accelerate this vision by an order of magnitude. What is that piece?
So I think like I think stuff like what Optimism is doing with Bedrock is actually really interesting. So like, I mean, I guess like Celestia is also kind of heading towards this. So this is sort of the thing, right? It's like there's a bunch of things that are being built right now that are on testnet. As soon as they are on mainnet, that will vastly accelerate the adoption of these systems. But yeah, basically the ability to have like, basic frameworks for building rollups that have all of the infrastructure encompassed in them, where you could just sort of almost like Cosmos SDK style, just like add modules to them. So maybe just like a module packet manager ecosystem on top of things like Celestia would be a really good way to like accelerate the development of these rollups. So you can just like similar to Cosmos chains. I don't know if this is something that you guys do already, but similar to Cosmos chains, just like install modules for like common functionality. Of course, you could just have like a VM for everything, but like there are definitely other kinds of modules, especially if you're building like a purpose-built rollup.
Yeah, absolutely. Arjun took the words out of my mouth. I mean, this is kind of what I was getting at earlier about these standard interfaces. So basically, like the vision would be there's a set of like core components that you need when you're building your roll up software, right? You can have sort of like a mempool component. You can have like a sort of like leader selection component. You can have the execution component. There's a bunch of different things, like a networking component as well, and then you could have a bunch of different versions of it, sort of like the Cosmos SDK, and choose to plug in the ones that you want to use and swap them out. The thing is, and I think there's a lot of people building in this direction. Um, the OP stack and Bedrock being one of them. Um, but the thing is that I think there's going to be a lot of duplicated effort because a lot of people are building sort of different with different interfaces or defining the stack in a different way, and so they won't really be compatible with each other. So I'm kind of keen on establishing a set of standard interfaces so that all these different components are not, kind of redundant or incompatible. However, I mean that's much easier said than done, but it's something that I think should happen because it's kind of the first thing that needs to be sorted out so that we can all kind of contribute towards this stack together, right, as like a general public good rather than like each be working in silos.
Yeah, I agree with that. There's this like really interesting kind of, I guess it's both good and bad, right? It's good to have like the competition that exists in the space right now towards building these like modular blockchain ecosystems, which there's so many different ecosystems that are being built now. And like the competition that exists in that space is really positive because it like ensures that everybody's held to high quality. This is kind of the same as like what exists in the bridge ecosystem as well. But it's also challenging because it's like harder to standardize. It's harder to like get to something that is going to make sense for everybody. And like that naturally then means you have to like go through the complexity of building adapters and other kinds of tooling and infrastructure on top that adds like just overhead for everything that you do. Um, but yeah, I guess maybe this is a thing that once we hit the depths of the bear market, um, maybe this is a thing that will be more uh, tangible to people where they'll be like, okay, well, all right, nobody is necessarily focusing on growing as fast as possible now. Let's focus on actually like working together on building things the right way.
It's gonna get worse.
I don't know.
It's gonna get
uh,
worse. It's super interesting side quest real fast being on this like the last 7 days on crypto and everything that's going on because I joined crypto full time this year, so like I was just like vibing and everyone was like, oh my god, how are you doing? And I'm like, I'm fine, like what's going on, I'm great. And I just didn't realize the magnitude of what had just happened because I was just like frolicking through the field of crypto and I'm like, this is so great, I love it here. And I'm realizing like, oh shit, no, we're not, this is not the worst it's gonna get. Anyways, so two more questions before we wrap up here. Obligatory, where do you guys see the space heading in the next year, in the next 5 years? Would love to hear from everyone on this, actually, one by one.
One thing that I think we might start seeing is like a wider array of options regarding like how decentralized different parts of the stack are. So like fully centralized data availability layers, they're going to have like a price advantage, right? Because they don't have to be decentralized. But maybe that's reasonable for something like, I don't know, if there were like a Twitter chain in the future, then they would just end up owning all the data. And that maybe that's okay, right? It's like you get some benefits. You get like a public API, you get like you can verify correctness of anything that happens on Twitter, but you just can't like run the infrastructure yourself. So that I think that's like one direction it can move in.
So a year from now, we will have the first data availability layer on mainnet, which will be Celestia. And so I think that's going to be, a big moment for modular blockchains and sort of the broader movement. And hopefully there'll be a lot more. Maybe there'll even be 4844 will go live on Ethereum, and other. I'm not really sure the roadmap of other DA layers, but I think that'll be really exciting because it's fundamentally going to reprice block space, and make block space just so plentiful and so cheap. And I think that's going to be really cool because it's just going to like make it so much easier to experiment and innovate and lower the barrier to entry and also the cost to users. So I'm very excited for that in year one. And then I would say 5 years from now, I think a majority of the modular stack will be built and functioning. In fact, I mean, I think all of it, but to varying degrees of maturity. And I think we're going to have a world, we're going to be living in that world that we're all envisioning, where a developer can just literally, write a few lines of code, mix and match a few different modules, and then press a button, and all of a sudden a new blockchain spins up, and it's fully decentralized and integrated with like a broader ecosystem. And I think that's just going to unleash an unbelievable amount of innovation. In the same way that, when Ethereum made it possible to build a D app with just, writing a few lines of code, it's going to be a similar thing, but on a even bigger scale. So that's what I'm really excited about.
Yeah, it's a really good question. So I think within the next like few weeks, perhaps even shorter, Connext is going to be live with our upgrade that allows us that moves us towards being this kind of like modular system for cross-chain communication. And I think over the next year, what we hope is what we want to see is like is to see like developers exploring this idea of having applications built in an asynchronous environment across multiple chains or multiple domains. And I'm personally really excited about that prospect, because I think it's going to be a fundamental shift in the way that people think about building applications. It's a necessary shift. There's no real other way to get around it. But I think like we're going to have to really like rethink a lot of. We're going to have to take like application development away from this like very simple synchronous thing that we do that basically represents. There's basically like AP comp sci level computer science where you're just interacting with like code that's running inside of one singular box, to web development, right? And like the challenges of web development and distributed systems development. So it's going to be quite interesting to see how the space like moves to solve that. I think one of the other things that we're going to see, as Nick mentioned, is the commodification of block space. So we're going to move away from this paradigm of everybody is like terrified of building applications that are going to cost too much money, and like gas prices rising at some point in the future because of like a future bull market, and move towards a world where people are actually able to build whatever application they want, and there's enough kind of like space for everybody. I think that's going to be like a fundamentally very, very interesting change. And what I hope is that over the course of the next 5 years, those two things, moving to this asynchronous environment for communication, having like purpose-built rollups and the commodification of blocks, because like you can expect that once block space is commoditized, it will become specialized. That's just generally what happens in any kind of market, is like when you have commodification of a product, you then get like a lot of like explicit specialization to try to like sub-segment a market. And so when that happens, you're going to have block space that is specifically targeted for compute, or for some specific kinds of compute, like parallelizable compute, block space that is specifically targeted for storage, and other kinds of things. And I think when you have that, and when you have asynchronous communication between these different systems, you will start to see the first real full stack applications on blockchains. I'm not just talking about like, here is 500 lines of Solidity code that lets you like operate a very, very simple DEX. I'm talking about like building a real end-to-end platform on top of a blockchain that exists as public infrastructure forever, and where every portion of that stack is fully decentralized. I think that's what excites me the most, is like heading towards that, as I mentioned earlier, the like world computer phase.
Okay, did everyone get a chance? Yes. Okay, cool. And then final question, and then while you guys are answering this, it would be great if you guys could plug tweets into the top of the space so that people can just click on them and not have to go searching for them. So perhaps there's a video, perhaps there's an account, perhaps there's a link you want people to follow. You can do that by going to the tweet and then hitting share, and there'll be an option to share it in the space. So maybe starting with Nick, what do you have coming up for the rest of the year and into Q1 of next year? What are you excited about, and what should people look forward to, and how can people stay in touch with the progress?
Great question. So there's a few exciting things that we're working on internally. One is the Modular Fellows Program, which is going really well, thanks to Josh, who is in the audience. And that will be wrapping up towards the end of the year, early next year. Early next year in Q1, there are two big milestones. And the first is going to be, we plan to launch a grants program. So that will really give a lot of builders that are kind of on the sidelines an opportunity to jump in full-time on Modular and experiment. There's just so many different cool ideas that, have yet to be tried. And this will kind of be a call to action to all those people who are aware of these opportunities and eager to get involved. And then the last thing is going to be, we are going to be launching our incentivized testnet in Q1 of next year. And there'll be lots of opportunities for validators and node operators to get involved. So yeah, big action-packed end of the year and early next year for us.
How about Eclipse?
Okay, yeah. So the big thing is Q1, we're going to be launching our testnet. We're launching on Celestia, which we're really excited about. We have these 3 testnet chains that we're launching. One is for DeFi, one is for more like consumer gaming type stuff, and the third, we think it's probably going to be for token incentivized physical infrastructure. So things like Helium or decentralized proxy networks, decentralized battery networks, things like that. So yeah, that's what we're working towards. We'll open source our repo, so that's exciting, and that's probably the biggest priority. So yeah, part of it is bringing on Solana projects that are like starting to hit these sorts of needs where they need to customize further, and another part is just getting entirely new projects that just can't fit on any existing L1, and they're uniquely suited to Eclipse.
Cool. And how about Arjun?
Cool. Yeah. Before I show Connext, I just wanted to quickly say something. So this space unfortunately happened at a very inauspicious time. I'm really, really glad that everybody who's attending, wow, we have 850 people attending. I'm really happy that like everybody who's attending this is attending, and it's obviously been a fantastic discussion so far. I also just wanted to just take a moment and say like, what's happening right now really sucks. Like this sort of market implosion caused by, the idiocy of centralized actors is the exact kind of thing that crypto is supposed to fix. And so it's super painful to see it happening over and over again in this ecosystem. I think one of the unfortunate reality is like, it's not really the people that are involved in, like creating these sorts of really broken financial systems that end up paying the costs of them. Those costs are actually paid by end users and by individuals, retail users, and many of whom, especially in this cycle, are people coming from, relatively underprivileged backgrounds or from places in other parts of the world where they are putting a very significant amount of their personal capital into this ecosystem. And I think like when this happened last time with like, the Terra collapse and with 3AC, that of course meant that people lost their life savings. They lost a lot of like what, like a lot of like real things for them that are an important part of their own personal livelihood. There's a real like cost to this stuff. I think that's something that like people forget, like especially once you've been in the space for a while and you've been through a lot of cycles, you kind of forget like when crashes happen, like people lose everything. So yeah, I wanted to kind of say like if that's you and if you're experiencing that right now, like you're not alone. A lot of other people are going through that too. This is one really, really awful step in a longer kind of journey that you're going to be experiencing. If you want to talk about it, just DM me on Twitter or join our Discord and DM me there. Happy to chat with whoever wants to about it. Cool. Switching back to Connext stuff. So as I mentioned earlier, Connext is going live with our upgrade within the next couple of weeks. We're super excited about this because it is the start of what we think is going to be this like very, very interesting trend in building these like asynchronous cross-chain applications. We're very, very excited to see what people will build. And as a part of that, we're really like keen to get developers interested in these ideas and talking about how to like build these kinds of applications. So if this is something that appeals to you, if it's a problem set that like you find interesting, join our Discord and keep an eye out for the updates that we'll have coming over the next like few days. Yeah. Thanks so much.
Amazing. And then quick plug for Fuel. I shared a tweet from Fuel here where they did a really sick podcast where kind of for the first time we talk about the roadmap publicly and a lot of stuff that has been discussed really deeply, I think, within the fuel echo chamber, but I think the greater community doesn't really know about. So I'm just going to quick fire some really cool things that Sway, our DSL, has. So Sway, and I was just looking at a tweet today where I think it's called Curve, DFX Dex pool, yeah, named Curve, was hacked and lost like $4 million worth of ETH today because of through a reentrancy attack. And the Sway compiler, so Sway is our programming language that's based on Rust. At the compiler level, we'll have a reentrancy checker where it will let you know as a developer if you have a potential vulnerability for reentrancy, and it won't even let you build and much less deploy the contract without addressing that vulnerability. And so there's this list that I'll try to find and share real quick that keeps track of all of the reentrancy attacks that have happened in the last, like, I don't know, couple of years. And it lists them all in chronological order. And for Fuel and Sway, this list theoretically should be none. There will never be a reentrancy attack on code written in Sway. And right now we're live on testnet, and it's been super exciting. Like someone mentioned here, like throughput, really high throughput cases like gaming. And over ETHSF, we saw a team built what is it called? RuneScape. And they like dubbed it Fuelscape, and they built it all fully on chain, and that was super lit. And there's a bunch of really cool things about Sway and Fuel that I'll just leave it up to you guys to check out. But thanks everyone for being here. If there's any final plugs that you want to do, now would be a great time. We're just perfect on time. Thank you, Nick, Arjun, um, Eclipse. Oh my God, I'm sorry. Is it Neil? Yeah, Neil.
Yeah, Neil. I should
Neil,
have
you're
joined
the
off my
best.
personal account. Yeah,
No,
my bad.
no, all good, all good. And yeah, I'll leave you guys to do any final plugs, and then we'll close this out. Okay, I love when there's no final plugs. That just means we did a good job. The agenda. All right, thanks, y'all.